To a very good evening to Dr. Hua, who's watching right now. And we are from Group Data Diggers. And we will present our uh, research, which the title is The Effect of Demographic Changes Toward Economic Growth in Japan. So I will start the presentation with introduction, which I will explain on the background of the Japan, where Japan faces significant challenges from a rapidly aging and declining population. And over 29% of the population is aged 65 or older, that leading to the world's highest elderly dependency ratio. Next, for our key issues, aging population and declining birth rates result in fewer working age individuals, and the negative population growth since 2010, declining from 228 million in 2010 to 224 million in 2023. And then a high age dependency ratio, which is 70.3% in 2002, increases economic burdens. And our research focus is we want to analyze the relationship between GDP per capita growth and demographic factors, which indicate age dependency ratio, working age population, fertility rate, life expectancy, and population growth. And our objective is we want to explore how demographic shifts affect the Japan's economic growth, and we want to provide a policy recommendations to address these challenges. I'll pass to the next presenter.
Next is a literature review. First, population growth play a significant role in economic development. Study like Domingo suggests that rapid population growth can strain resources, especially in developing region. Next, the age dependency ratio, which measure the proportion of dependents to the working age population, is crucial in understanding the economic implication of aging. In terms of aging population, Brickner and Lee and mentioned emphasize that also aging and reduced workforce participate investing in education, technological innovation, and productivity and change measure can mitigate the negative impact and support long-term growth. The relationship between the expectancy and economic growth is also significant. Sunde and Servalati argue that longer life expectancy can enhance human capital by encouraging investment in education and health, which ultimately drive productivity and economic performance. Finally, fertilized rate are another demographic factor influence growth. Lee found that higher fertility rates tend to limit economic growth, especially when human capital is underdeveloped. In contrast, declining fertility and increasing investment in human capital can support long-term economic progress. I will pass to the next presenter.
Okay, so my name is Chiew. I will present the methodology we use to study the impact of demographic changes on Japan's economic growth. So first is the descriptive statistic. We will use the descriptive statistic to summarize the data set using measures like mean, median, and standard deviation. So this will help us identify the trends and outliers and to ensure our data is well prepared for the analysis. The next one is unit root test. Using the ADF test, we check the stationarity of our time series. This step was so important because as non-stationary data can lead to misleading or the inaccurate result. We also use the Johansson co-integration test, which works within the vector autoregressive, or we call it as VAR model framework. This test will determine whether our variables have long-term equilibrium relationships or not. And we also use the normalized co-integrating vector analysis. After confirming the co-integration, we will quantify this long-term relationship by normalizing one variable, typically the GDP per capita growth, to interpret how demographic factors influence it. And also we will estimate the error correction model or ECM. To analyze both short-term dynamics and long-term equilibrium, we will use ECM. This model also measured how quickly the system adjusts back to the equilibrium after the shocks. And then a Granger causality test will also be applied within the ECM framework to identify the directional relationships between the variables. And this will help determine whether demographic factors can predict changes in GDP growth over the time. And lastly, we will conduct the diagnostic test to validate our models. This test included the JB test or Jagbera test for residual normality, the Bruch-Goffrey LM test for autocorrelation, the heteroscedasticity test for variance consistency, the Ramsey reset test to ensure the model's functional form was appropriate, and the Kuzam test to, to check the parameter stability over time. So through this rigorous methodology, we ensure that our analysis is both statistically sound and reliable. So I will now pass it to Leslie to present the result and discussion.
So, good evening, Doctor and my fellow group mates. So, my name is Sanam Padan, and I'll be presenting on this part. So, as we can see here, the table summarizes key statistics for five variables, as have been mentioned by the previous presenter. So, for the average GDP CGR is 37 at 1.83, which means that it's slightly higher than the median, indicating a small rightward skew. Meanwhile, for WAP and LE are fairly balanced. For WAP, it's showing a slight leftward tilt. For FR is stable and TP has minimal skew. And then it shows that GDP CGR has the most variability, followed by ADR and WAP. And meanwhile, for FR and LE, it shows little variation. Skewness shows that GDP PCGR has a small positive skew, while WAP and LE are slightly negatively skewed. For FR and TP, it shows more noticeable skew. Okay, for the last one is GDP, PCGR, and FR. It shows have high kurtosis, which means that their distributions are more peak, while the others are more evenly spread. This key statistic is used based on 34 observations. Okay, the next slide is for stationary test. Okay, for the stationary test, we use augmented decay filler, which is ADF. So for most variable, the data was not stationary at the level, which is common for macroeconomic data. However, after we first differencing, all variables become stationary, as shown by significant p-values, which is significant at 5 level. And specifically, LRADR, LRWAP, LRFR, LRLE, and LRTP all showed stationary after differencing, which confirming that the data is suitable for our further analysis. And then we also conduct, okay, next slide. Okay, we also conducted the Johansson and Julian co-integration test. So the result shows that strong evidence of co-integration. For the first comparison, both the max and trace statistic exceed their critical values, which indicating at least one long-term relationship. And then in the second comparison, the statistics suggest that at least two co-integrating relationships. And the third one that it shows that comparison shows the possibility of three relationships, and the last one is at the end. The fourth comparison indicates at least four co-integrating vectors. So for the fifth and sixth comparison, the statistic fall below the critical values, which indicating no more than four co-integrating vectors. Overall, the test overall this test that it finds that four co-integrating relationships, suggesting that long-term equilibrium among the variables. That so due to this existence of the co-integrating, we need to conduct vector error correction model as has been mentioned by Chiew Xing Ying, to analyze short-term dynamics while maintaining the long-term relationship. Okay, next slide. Okay, for the normalized co-intervening vector, it shows how important long-term links between demographic vectors and GDP per capita, which is GDP CGR. So we can see that the value for the constant term is at 0.3 at 5 at, it sets the baseline for GDP PCGR when other factors are constant. And for the LGDP, which is LRADR, it says that a 1% increase in the H dependency ratio, which is LRADR, raises GDP per capita growth by 0.25%. It's suggesting that higher dependency ratio may benefit from intergenerational support. Okay, for the LRWAP, one increase in the working LRWAP boosts GDP per capita growth by 0.42 percentage, emphasizing the importance of productive workforce. And then for the LRFR, a 1% rise in that variable, it lowers the GDP per capita growth by 0.09, which reflecting the economic cost of higher fertility. And then the next one is life expectancy. Okay, so for this part, a 1% increase in this variable, it decreases GDP per capita growth by 0.98, likely due to the financial burden of aging population. And the last independent variables is LRTP. It has been saying that a 1% increase in total population increase GDP per capita growth by 0.61%, showing how population growth fuels economic activity. And then we also conduct ECM. Next slide. Okay, for the ECM, it shows how the variable respond to changes in the short and long term. So the error correction term ECT is positive but not significant, which indicating that the short-term deviation from long-term equilibrium aren't being corrected effectively. In the short term, the second leg of GDP growth significantly reduced GDP growth by 164.2%, possibly due to overcorrection. And then the other demographic factors like age dependency ratio, working age population, fertility rate, and total population have no short-term effect. Meanwhile, for life expectancy, it shows a significant negative effect in the second leg, which reducing GDP growth by 145.4%, possibly due to the cause of an aging population. And then for the analytic step, we use JB, heteroscedasticity, and other cosms and cosm risk squared, and AR. Okay, for the genetic test, confirm the model's reliability with normally distributed residual and no serial correlation. However, there may be some various changes in the heteroscedasticity, but the model is stable and correctly specified. In conclusion, for this test, the model is reliable, but attention is needed for potential heteroscedasticity. Okay, the last one test that we conduct is gradual causality using VECM. So because there's existence of co-integration, we need to further the analysis by using this test. So the edge dependency ratio, which is LRADR, is significantly influence the fertility rate, suggesting that changes in the dependency ratio, it can predict fertility rate fluctuations. Meanwhile, for working age population has a strong impact on multiple variables, including GDP per capita growth and adult age dependency ratio, fertility rate, life expectancy, and total population. Which this means that it indicates that the changes in the WFP drive significant demographic and economic trends. So for the LRTP, it significantly affects GDP per capita growth with a growing population boosting economic activity, but it potentially straining resources if not matched by economic growth. Population changes also impact the age dependency ratio, working age population, fertility rate, and life expectancy. So the relationship between these variables, only this one, only LRWAP and LRTP shows bidirectional relationship. Meanwhile, for the other variable, it shows unilateral relationship. Okay, I'll pass the next slide to the next presenter, which is Davy. Thank you.
And I'm David, and I will present about the conclusion and the recommendation. For the conclusion, Japan faced significant demographic challenge, including an aging population, low fertility rate, and a shrinking workforce. And this is linked to higher edge dependency ratio and reduce productivity and increase pressure on public finance. And to solve these challenges, the strategy intervention are essential, such as investing in human capital, promoting technological innovation, and improving labor productivity, managing fertility rate, and strengthening health and education system are also critical to ensuring workforce quality and economy resilience. And and the next one is the conclusion for the finding of this study. The first one is demographic dynamic, like the adaptive dependency ratio and working age population significantly impact GDP growth, while the birth rate and life expectancy show a negative correlation with GDP growth. And the other factors highlight the role of demography trend in economic outcome. The second is the econometric analysis confirm the variable become the stationary after the first interpretation and consists with macroeconomic data behavior. And the Johansson co-integration test is identified for long-term equilibrium relationship and emphasizing the interdependence of demography and economic factors. And last but not least, the error correction model review with short-term adjustment to demographic change, underscoring the need for long-term policy planning. And this finding underscores the importance of aligning demography and economic strategy. And next, I will present the recommendation part. And the first one we want to recommend is the workforce policy should focus on increasing participation for women, senior, and other underrepresented group, and flexible work arrangement and childcare support will play a key role. And the second is immigration policy should aim to attract skilled foreign labor and to increase the workforce shortage. And financial incentive and policy promoting later retirement will help increase fertility rate. And the third one is investment in automation and innovation are vital to counter the declining labor supply and boost the productivity. And furthermore, diversifying into emerging sector and reskilling worker will enhance Japan's economic adaptability and resilience. And this measure can significantly mitigate the impact of demography challenge. And this study highlighted the profound impact of demographic trend on economic growth. For Japan, the aging population and shrinking workforce pose significant challenge, and the strategy investment in human capital, technological innovation, and the proactive demography policy are essential to navigate these threats. And the key takeaway is that by addressing these challenges, Japan can transfer demographic issue into opportunity for sustained economic growth. And that's all from us. Thank you.